If you're an aviation enthusiast, you need to hear this. Welcome to Space Fact Fusion. The vast expanse of the Pacific Ocean, dotted with islands and continents, presents a unique challenge for air travel. This immense body of water, covering more than 63 million square miles, is the largest and deepest of Earth's oceanic divisions. Its sheer size and the scattered nature of its islands make it a fascinating yet complex area for aviation. A casual glance at a traditional map might lead one to believe that planes avoid flying over this immense body of water. However, the reality is far more intricate. The curvature of the Earth and the way maps are projected can be misleading, making it seem like planes are taking longer indirect routes. Why then do flight paths often appear curved, skirting the edges of the Pacific, rather than taking a seemingly more direct route? The answer lies in the concept of the Great Circle Route, which is the shortest path between 2 points on a sphere. These routes often appear curved on flat maps, but are actually the most efficient paths. The answer lies in a fascinating interplay of geographical realities, safety regulations, fuel efficiency, and meteorological factors. Pilots and flight planners must consider jet streams, turbulence, and potential emergency landing sites, all of which influence the chosen flight path. Unraveling this puzzle requires us to delve into the world of aviation and understand the intricate considerations that go into planning every flight path. From the role of air traffic control to the importance of fuel management, each aspect plays a crucial part in ensuring a safe and efficient journey. This essay aims to debunk the myth that planes avoid the Pacific Ocean, shedding light on the real reasons behind these seemingly circuitous routes. By understanding the science behind flight paths, we can appreciate the careful planning that goes into every flight. By examining the science and logistics of air travel, we can gain a deeper appreciation for the complex decisions made to ensure safe and efficient journeys across our planet. The collaboration between engineers, pilots, and air traffic controllers is essential in navigating the vast expanse of the Pacific. Join us as we embark on a journey to uncover the truth about why planes don't fly directly over the Pacific Ocean. Or do they? Through this exploration, we will reveal the hidden intricacies of aviation and the marvels of modern flight. One of the primary reasons for the misconception surrounding trans-Pacific flights lies in our perception of the Earth itself. Many people still visualize the world using flat maps, which are inherently flawed in representing the true nature of our planet. We often rely on flat maps to visualize our world, but these maps fail to accurately represent the Earth's spherical nature. Flat maps distort the sizes and shapes of continents and oceans, leading to misconceptions about distances and directions. This distortion leads to a fundamental misunderstanding of distances and routes when it comes to air travel, particularly over large bodies of water like the Pacific. The vast expanse of the Pacific Ocean is often misrepresented, making it seem larger or smaller than it actually is. Imagine a string stretched taut between 2 points on a globe. This string represents the shortest distance between those points, known as a Great Circle Route. It's a concept that is much easier to understand when visualized on a three-dimensional sphere. This string represents the shortest distance between those points, known as a Great Circle Route. Great Circle Routes are the most efficient paths for air travel, minimizing both distance and fuel consumption. When this route is projected onto a flat map, it appears curved, sometimes even arcing far north or south of what seems like a more direct path. This curvature can be confusing, but it is a direct result of trying to represent a three-dimensional journey on a two-dimensional surface. This curvature is crucial for understanding flight paths over the Pacific. Pilots and airline route planners use these Great Circle routes to ensure that flights are as efficient as possible, even if the paths look unusual on a flat map. Airlines prioritize efficiency, and flying along a Great Circle route, despite its seemingly indirect appearance on a flat map, actually saves time and fuel. This method of route planning is essential for long-haul flights, especially those crossing vast oceans. It's the shortest distance between 2 points on a sphere, even if it doesn't look that way on a two-dimensional representation. Understanding this concept helps demystify why planes take certain routes that might seem counterintuitive at first glance. Therefore, the perception that planes avoid the Pacific is often a result of viewing flight paths on flat maps that distort the reality of our planet's shape. These maps can make it seem like flights are taking longer, more convoluted routes when they are actually following the most efficient paths. In actuality, planes are often taking the most direct route possible, following the curvature of the Earth to minimize distance and maximize efficiency. This understanding is key to appreciating the complexities and intricacies of modern air travel. While efficiency is a significant factor in determining flight paths, it is not the only consideration that airlines must take into account. Safety remains the paramount concern for any airline, and this is reflected in the meticulous planning and rigorous protocols that are followed before every flight. Over vast expanses of water like the Pacific, where diversion airports are scarce, special regulations and considerations come into play. These regulations are designed to ensure that even in the most remote areas, there are contingency plans in place. One such regulation is ETOPS, which stands for Extended Range Twin Engine Operational Performance Standards. ETOPS is a critical component of flight planning for twin-engine aircraft, especially on long-haul routes over oceans and other remote areas. ETOPS dictates how far a twin-engine aircraft can operate from the nearest suitable airport for diversion in case of an emergency. This ensures that, should an engine failure or other critical issue arise, the aircraft can reach an alternate airport within a specified time limit, thereby safeguarding the lives of everyone on board. This regulation ensures that, in the event of an engine failure or other critical issue, the plane can safely land at an alternate airport within a specified time limit. The importance of this cannot be overstated, as it provides a safety net for flights over areas where landing options are limited. The vastness of the Pacific Ocean poses a challenge in meeting ETOPS requirements. The sheer distance between suitable diversion airports means that flight paths must be carefully planned to ensure compliance with ETOPS regulations. With fewer islands and suitable diversion airports compared to other oceanic regions, flight paths are often strategically planned to remain within a safe distance from potential landing sites. This strategic planning is a testament to the aviation industry's commitment to safety and reliability. This is not to say that flying over the Pacific is inherently unsafe. Modern aircraft are designed with advanced technology and multiple redundancies to handle a wide range of scenarios. Modern aircraft are incredibly reliable, and airlines adhere to rigorous maintenance schedules and safety protocols. These measures ensure that aircraft are in optimal condition before every flight, further enhancing safety. However, the principle of caution dictates that flight paths are carefully calculated to mitigate risk and ensure the safety of all passengers and crew on board. This careful calculation involves considering multiple factors, including weather conditions, aircraft performance, and the availability of diversion airports. Beyond geographical considerations and safety regulations, meteorological factors also play a crucial role in shaping flight paths over the Pacific Ocean. The jet stream, a band of strong winds high in the atmosphere, can significantly impact flight times and fuel efficiency. These winds, often blowing from west to east at high altitudes, can either assist or hinder an aircraft's progress depending on its direction of travel. Flights traveling eastward can take advantage of the jet stream's tailwinds, reducing flight time and fuel consumption. Conversely, flights traveling westward often need to adjust their course or altitude to minimize the impact of headwinds. Furthermore, the Pacific Ocean is known for its unpredictable weather patterns, including typhoons, cyclones, and areas of severe turbulence. Airlines carefully monitor weather forecasts and use sophisticated radar systems to navigate around these potentially hazardous conditions. Pilots may choose to deviate from the most direct route to avoid storms, turbulence, or areas of volcanic ash, prioritizing passenger comfort and safety. These deviations, while sometimes adding to the overall flight time, are essential for ensuring a smooth and secure journey. Section 5. Fuel efficiency, the economic route. In the world of commercial aviation, fuel costs represent a significant portion of an airline's operating expenses. Finding the most fuel-efficient routes is not only environmentally responsible, but also crucial for maintaining profitability. As mentioned earlier, Great Circle routes are inherently more fuel-efficient because they represent the shortest distance between 2 points on a sphere. By following these routes, airlines can minimize fuel consumption, reducing both costs and their carbon footprint. Even seemingly small deviations from a Great Circle route can impact fuel consumption. Factors like wind conditions, altitude, and aircraft weight are carefully calculated to optimize fuel efficiency throughout the flight. Airlines constantly analyze weather patterns, air traffic control data, and other variables to determine the most economical routes. These calculations ensure that each flight operates at peak efficiency, balancing passenger comfort and on-time performance with environmental responsibility and cost-effectiveness. In this part, we delve into how flights are meticulously tracked as they traverse the vast expanse of the Pacific Ocean. It's a fascinating process, really, involving state-of-the-art technology and precise coordination. Interestingly enough, not all flights steer clear of the Pacific. Some routes, due to specific logistical reasons, do cross this enormous body of water. It's all about finding the most efficient path for each journey. Now let's uncover the logic behind these flight paths. Airlines carefully consider factors like weather patterns, fuel efficiency, and air traffic regulations. It's a complex puzzle that ensures safety and efficiency for every flight. Looking ahead, the future of trans-Pacific aviation promises even more advancements. With emerging technologies and evolving strategies, we can expect even more efficient and sustainable flights across the Pacific in the years to come. Please like, comment, and subscribe to Space Fact Fusion for more exciting content.